In this question, which is from application of derivative, we say a ladder which is 5 meter long is leaning against the wall. So let's say if I take one ladder, let's say this be the wall and the ground, and I'm going to take one ladder. Let's say this be the ladder which is leaning against the wall. Now this ladder, later it says that this ladder is pulled from the bottom, right, and along the ground and away from the wall at the rate of 2 centimeter per second. So what we can observe that this ladder, which is pulled, right, if it is pulled like this, it's going to be like this. It will be its new position, right? As you can see, it's pulled in this direction. It's pulled in this direction at the rate of 2 meter. It's 2 meter, no, 2 centimeter per second. The rate at which it is pulled. Now I also must show the initial position of the ladder, which was this, I suppose. That was the initial position of the ladder is this. So let's say this is the initial position, say A, B, and I take this point as O. You know, this angle is 90 degrees. Now what we have to find out, how fast is the height of the wall is decreasing when the foot of the ladder is 4 meters away from the wall. That means we have to find out the rate at which this is going down, right? This part is going down, the rate at which this is going down. So what other information do we have? I should write it down. We have given the length of the ladder, which is 5 meters. And I'm going to take AO as X, say for example, no, take this as Y, this as Y, and say this is X. Now we have one relation here, that is X square plus Y square using Pythagoras theorem is equal to 5 square. So we can say that X square plus Y square is equal to 25. Now further, we know that rate at which this is being pulled, that means we know dx by dt. You know dx by dt as 2 centimeter per second. So I can write here only. That is, this is dx over dt is given as this. And what we have to find out is dy by dt is what we have to find out. As I told you, the rate at which it is pulled. Now what I can do is to apply differentiation over here. And now let's find out the differentiation first. So this is 2x plus 2y is equal to 2y. We are differentiating with respect to x, so it should be dy by dx with respect to t. Let me do it once again. Differentiating both sides with respect to t, right? This is with respect to t here. So we can say this is 2x dx over dt plus 2y dy over dt is equal to 0. I can take 2 common and say dx times dx by dt plus y times dy by dt is equal to 0. Now next, we know the value of x here. Do we know? Yes. From here you can see when x is, so let's say when x is 4, what should be y? You know that 3, 4, and 5 are Pythagorean triplets, so I can say y is 3. When x is 4, y is 3. Now, technically, we have to find dy by dx at x is equal to 4. That's what the question. Now, what I can do here is from here, I'm going to replace these values here. I'm replacing x here. I'm replacing x with its value, that is 4, dx by dt, which is 2, that is 4 into 2, plus y, which is calculated as 3, and dy by dt is what we have to get. On the other side, there is 0. So clearly, I can say that dy by dt is equal to, this is what, 4 into 2 is 8. So it's minus 8 divided by 3, right, centimeter per second. It's as it is dy by dt. Y is receding down at the rate of this. And the negative sign indicates that this height is decreasing. That's very obvious that when this is increasing, this has to decrease. So you may write down this at x is equal to 4. So I'll also declare this to be the final answer.